Hello class, we're about to start lessons 5, 6 through 5, 8. Now 5, 6, we're supposed to cover problems 1 through 4 all, starting on page 542 to 544. And again, just like we've done traditionally, I would just pick out a few problems to do here. So I'm going to do basically a couple problems, problems 2 and 4. So let's start. Problem 2 actually starts on page 543. And problem 4 is actually on page 544. So with problem 2, it says if three resistors having resistances R1, R2, and R3 are connected in parallel, their combined resistance R is modeled by the formula. So we have R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So we have 2A. It says determine R if R1 is 4 ohms, R2 is 8 ohms, and R3 is 12 ohms. So we have R is equal to 1 over, it'll be 1 over 4 plus 1 over 8 plus 1 over 12. Now we could put this in our Desmos calculator. So we could do 1 divided by, and then here we would have to break out a few parentheses here to make it a little bit easier. So we could have 1 divided by 4, close that parenthesis, and then plus, and then another parenthesis, 1 divided by 8, space, close that parenthesis, plus, parenthesis, 1 divided by 12. Okay, and then what we would do is we would round this to 2 decimal places, and it'll be 2.18 ohms. And that is it for A. Now we move on to B. It says simplify the complex fraction on the right side of the original formula. Okay, so basically what they want us to do, instead of writing the R equals, they want us to simplify this side of the fraction. So we would have 1 over R1 plus 1 over R2 plus 1 over R3. So what we need to do is find a common denominator here of R1, R2, and R3. And the common denominator is R1, R2, R3. So what we're going to do, we're just going to concentrate on our denominator here. And we're going to multiply all of these by R1 times R2 times R3. Now remember, we're just concentrating on our, well, actually, no. I'm doing this as if we're going to get rid of our denominators. No, we just find a common denominator here. So the common denominator is R1, R2, R3, but this is how we would go about doing it. We know this is missing R2 and R3, so we'll take R2, R3 over R2, R3 and multiply by the 1 over R1. This here is missing R1 and R3, so we'll do R1, R3 over R1, R3 and multiply by the 1 over R2. And then finally plus, this is missing R1 and R2, so we'll do R1, R2 over R1, R2 times the 1 over R3. Okay, so now this will give us 1 over, this will be R2, R3 all over R1, R2, R3 plus, this will give us R1, R3 all over R1, R2, R3 plus, this will give us R1, R2 all over R1, R2, R3. Okay, now, so far this is still not simplified because we need to basically get this from the denominator, but we can combine the like terms. So this will become 1 over R2, R3 plus R1, R3 plus R1, R2. And all of this will be over R1, R2, R3. Now, we want to get rid of this here. And what we could do is this here. This is the same as saying 1 divided by R2, R3 plus R1, R3 plus R1, R2 divided by R1, R2, and R3. Now we know according to division, we could change this to multiplication and take the reciprocal. So this would be 1 times R1, R2, R3 all over R2, R3 plus R1, R3 plus R1, R2. And when we multiply that by 1, we know we would end up with R1, R2, R3 in our numerator. In our denominator, we have R2, R3 plus R1, R3 plus R1, R2. And this right here will be the final answer. So that took care of B. Now it asks us to go here to C. Now with C, it says redo part A using the new formula from part B. How do the answers compare? So we will have R is equal to R1, R2, R3, all over R2, R3, plus R1, R3, plus R1, R2. And now we will substitute. We have 4 times 8 times 12, all over 8 times 12, plus 4 times 12, plus 4 times 8. Now when we put this in our calculator, we're going to get the same answer. It would be 2.18 ohms. That'll be the same answer. So we will put the answers are the same. Okay, now we move on to the next page, and we will go here to problem number 4. Now with problem number 4, it says you decide to buy a new car, but you are concerned about the amount of the monthly payments. The amount A of each monthly payment is modeled by the formula A is equal to pi all over 1 minus 1 over 1 plus I to the n power, where P represents the principal or the amount borrowed, I is the monthly interest rate, and n is the number of monthly payments. So we look at 4A. It says here the car you are looking at costs $16,000 at 1% monthly interest. If you want to pay for the car over 60 months, how much will your monthly payment be? So we'll do A is equal to be 16,000. The interest they say is at 1%, so that'd be 0.01 all over 1 minus 1 over, and then we would have 1 plus 0.01, and then that'll be taken to the 60th power because it told us over 60 months. Now, once you put all this in your calculator, it will give an approximate value of $355.91. Okay, B. It says simplify the complex fraction on the right side of the original formula. So basically, they want us to take the pi over 1 minus 1 over 1 plus I to the n power. Okay? So now we have to find the common denominator here. The common denominator of 1 and 1 over 1 plus I to the n is 1 plus I to the n. So what we could do, we can make this 1 plus I to the n over 1 plus I to the n minus 1 over 1 plus I to the n. So when we do this here, this will give us pi all over 1 plus I to the n minus 1 over 1 plus I to the n. Now, what we must do next, whenever you have, and I know you've learned this most likely in another one of your classes, but let me just do it the way we did it before. This is really pi divided by 1 plus I to the n minus 1 over 1 plus I to the n. And just like we did in the previous problem, we'll change division to multiplication, and it'll be pi times 1 plus I to the n over 1 plus I to the n minus 1. So we'll put this over 1, and this will give us pi times 1 plus I to the n over 1 plus I to the n minus 1. And that will be your final answer for B. Now we come here to C. It says use the simplified formula to determine the monthly payments. How does your answer compare? So we're going to take this formula and substitute. So we add 16,000. The I is 0.01 times, we know 1 plus I will give us 1.01 to the 60th power, all over 1.01 to the 60th power minus 1. And it gives us approximately 355.91. So the answers are the same. Okay, all we did was just substitute, just to be sure. So that is it from section 5.5. So we actually 5.6, and we are done with section 5.6. Now we're going to go to 5.7. Okay, now with 5.7, we're supposed to be on pages 559 to 562, and it is 1 through 9 odd. So we're going to do problems 1, and then we're going to do problem number, let me see, problem 1, problem 5, and problem 9. Okay, so now for problem number 1, so we have using your calculator, determine the value of each number to the nearest hundredth if necessary. So we add the square root of 30, then we add 6 to the 1/2 power, and then we had the square root of 13 to the 4th power, and then we also have d, which is 9 to the 1/2 power to the 3rd. So using our calculator here, we'll first do the square root of 30, and they said round it to the 100th. So this would be 5.48. That'll be approximately. And then 6 to the 1/2 power, we'll take 6 to the, we know 1/2 is really 0.5. So that'd be 2.45. And these are approximations. And then next, we will do the square root. Well, first, let me put that parenthesis here. Okay, parenthesis. And then the square root of 13. And then we would take that to the, what's that, 4th power. And that'll give us 169. Now that's exact. And then now, we would do the next thing. We would add 9 to the 1/2 power, which is really 0.5. Close that parenthesis. And then we would take that to the 3rd power. And that gave us exactly 27. So that took care of problem number 1. Now, problem number 5 is actually on page 560. So when we look here at problem number 5, we will see that, all right, so we look at 5a, and it says sketch a graph of f of x is equal to x squared and g of x, which is equal to the square root of x, on the same coordinate system. Use the graphs to answer part B and C. Okay, so let me put these graphs up here. So what we're going to do, we're going to change the f of x to y, and we will have y is equal to x squared. Okay, and then for the g of x, we still will have y is equal to y is equal to the square root of x. All right, so we see the graphs here. Now these are the graphs that you should have. We know the blue graph is the g of x, and the red graph is the f of x. Okay, so that took care of A. Now we look here at B. They asked us, is x squared greater than the square root of x for 0 for x being greater than 0 but less than 1? And then it'd be no, the graph of f is below the graph of g for 0 is less than x, which is less than 1. Now remember here, these are the points here between 0 and 1. And if you notice, the g graph is above the x graph. So that's why we came up with our answer. Okay, now, and we're talking about in relation to the y value. Okay, now we come here to C. It says, is x squared greater than the square root of x for x is greater than 1? Okay, so when x is greater than 1, if you notice, the f of x graph is actually larger than the g of x graph. So the answer is yes. And then the graph of f is above the graph of g for where x is greater than 1. Okay, now we're going to embark on our last problem for section 5.7, which is problem number 9. So problem number 9, it says a shipping carton in the shape of a rectangular box has dimensions 12 inches by 24 inches by 17 inches. The diagonal D of a rectangular box is modeled by, let me write this formula out, D is equal to the square root of W squared plus, this is a lowercase l, squared plus H squared. Okay, where W is the width, L is the length, and H is the height. It says, will an umbrella measuring 34 inches long fit in the cart? So we'll put in the values. Now it tells us here that we have 12 for the width, and that's from the directions, 12 for the width. We have 24 for the length, and then we also have 17 for the height. So we substitute those values in. So this will end up giving us the square root of 1009, which is approximately 31.8 inches. So remember they asked us, would an umbrella measuring 34 inches long fit? It will not fit because we only got 31.8 inches and it's 34 inches, so it will not fit. Okay, now that was section 5.7. Now we need to move on to section 5.8 on page 567. And we have to do problems 1 through 9 odd. Okay, so with us doing problems 1 through 9 odd, I would think that we would do problems, let's do problem 3, 7, and also 9. So 3, 7, and 9 would be the problems that we would do here. Okay, so with that in mind, problem number 3, It actually starts on page 568, and it says solve each of the following equations algebraically and by graphing. Be aware of any extraneous roots. Okay, so we had 3a. We had the square root of x plus 5 is equal to 1. Now, we're trying to solve this for x, so we would square both sides. So this will end up being x plus 5 is equal to 1. Okay, we will subtract 5 on both sides, and x equals -5. Now, if you go back and put -5 in here, -5 plus 5, oh, I'm sorry, that's supposed to be -4, not 5. It's supposed to be -4. Okay, so if you put in -4, -4 plus 5 is 1. The square root of 1 is 1, so this checks out, and this is fine. So now we go to B. We have 10 times the square root of x plus 2 is equal to 20. Now we'll divide each side by 10 first, and the square root of x plus 2 is equal to 2. Now we will square both sides to get rid of that square root, and this will give us x plus 2 is equal to 4. Now we will subtract 2 on both sides, and x is equal to 2. Now if we substitute in 2 for x, 2 plus 2 is 4, square root of 4 is 2, and 2 times 10 is 20. So x equals 2 actually checks out. Okay, now we go here to C. Okay, C, we have the square root of 5 minus x is equal to x plus 1. Now remember, we need to get rid of this square root, so we would square both sides. So this will leave us 5 minus x here, and x plus 1 parentheses squared, we know that that is the same, and I'll write this on the side as x plus 1 times x plus 1, and then we could do the distributive property to be x squared plus 2x plus 1. So it'd be x squared plus 2x plus 1. And then here, what we would do, we would add x and subtract 5 on both sides. So this would be 0 is equal to x squared plus 3x minus 4. Now remembering how we did factoring before, this will factor out to be x plus 4 and x minus 1. So we'll set both of these equal to 0, x plus 4 equals 0, and x minus 1 equals 0. When you subtract 4 on both sides, x equals -4, add 1 on both sides, and x equals 1. Now, when we go through and check this, if we put -4 in here, -4, this will end up being +9. Square root of 9 is 3, but -4 plus 1 is -1, so -4 does not work. Now we would try 1. 5 minus 1 is 4. The square root of 4 is 2. And then 1 plus 1 is 2. So it'd be x equals 1 would be your final answer. Okay, now, the next problem that we're going to do is problem number 7. And problem number 7 is actually on the next page. So problem number 7, we have 7a. It says a pressure gauge on a bridge indicates a wind pressure P of 10 pounds per square foot. What is the velocity v of the wind if v is equal to the square root of 1000 p all over 3, where velocity is measured in miles per hour? So we will substitute. We will have v is equal to the square root of 1000, and then p is 10 all over 3. Now, if you put this will end up being the square root of 10,000 all over 3, which will give us approximately 57.7 miles per hour. That would be our velocity. So you could say V is approximately 57.7 miles per hour. Okay, now we go here to B. It says, what is the wind pressure if the wind is blowing 70 miles per hour? So we will have the square root of 1000 p all over 3 is equal to 70 because we're given a velocity here. So the first thing we should do is square both sides to get rid of this square root, because remember we're trying to solve for p here. All right, so this will leave us 1000 p over 3 is equal to 4900. Now, 1000 p over 3, we can multiply each side by 3 over 1000. This will leave us p is equal to, this will be 4900 times 3, which is 14,700 all over 1000. So this is actually equal to 14.7 pounds per square foot. So that is our final answer. 14.7 pounds per square foot. All right, now our last problem, and it's actually our last new problem for the course, is problem number 9. It says the Mesteller formula for calculating the adult body surface area A is equal to the square root of H times W all over 3,131, where H is the person's height in inches and W is the adult's weight in pounds. A is the surface area in square meters. Determine about the body surface area A of an adult who is 70 inches tall and weighs 200 pounds. So we have A is equal to the square root of 70 times 200 all over 3,131. When you put this in your calculator, it'll be approximately 2.11 square meters. Or you could write m to the second power. Either one is fine, square meters or m squared. All right. So that is A. So B, it says solve the formula for W. So we will have A is equal to the square root of HW over 3131. Now, this is telling us we want to get W by itself. So first thing we would need to do is square both sides. All right. So let me pull this over here. So this will give us A squared is equal to HW over 3131. Okay, now we have to multiply each side by the 3,131. So it'll be 3,131 A squared is equal to HW. Now we would divide each side by H, and our final answer would be 3,131 A squared all over H is equal to W. That is it. All right, so now we are done. If you have any questions, feel free to contact me. Thank you.